Hello learners. In today's lecture, we will study about factor analysis. I, Kriti Verma, deliver my lecture in factor analysis. First, before going to the factor analysis, first I want to explain about what is multivariate technique. Multivariate technique are largely empirical and deal with the reality. They possesses the ability to analyze complex data. For example, take the case of college entrance examination, where a number of tests are administered to candidates, and the candidates score high total marks based on many subjects are admitted. This system, though apparently fair, may at times be biased in favor of some subjects with a larger standard deviation. Multivariate technique may appropriately used in such situations for developing norms as to who should be admitted in college. The basic objective underlying multivariate technique is to represent a collection of massive data in a simplified way. Multivariate technique transform a mass of observation into a smaller number of composite scores in such a way that they may reflect as much information as possible contained in the raw data obtained concerning a research study. So, all multivariate methods are some variables dependent. Okay, so you have to remember this flowchart that all multivariate methods are some variable dependents. So here one question is there: are some variable dependent? If yes, then dependence method. If no, then independence method. Okay, so if dependence method we are opting, then how many variable are dependent? One or several? And if in the interdependence method is there, then are input matrix yes or no? If one, if there here if there is one variable are dependent, then it is it metric? If yes, then we will use multiple regression, and if no, then we will use multiple discriminant analysis. Now, how many variable are dependent? If several, then are they metric? Yes. If they are metric, then we will use multivariate analysis of variance. Or if they know, then we will use canonical analysis. Okay. Now, for if are they the variables are dependent, if no, and interdependence methods, and there is interdependence method, or input metric yes, then if input metric yes, then factor analysis we can choose factor analysis or cluster analysis or metric, yeah, or multivariate multiple dimension discriminant analysis system. So no, and if it is no, then there is non-metric MDS, and latent structure analysis. So these are the various steps. Okay, and so if all multivariate methods are there, means there are so many methods like multiple regression method, multiple discriminant analysis, multivariate analysis of variance, canonical analysis, then factor analysis, cluster analysis, metric MDS. So among these all methods we have to study about factor analysis. So factor analysis is what? Factor analysis when or in all multivariate methods, if are some variables dependent, if it is not dependent, then we will use interdependence method. Are inputs metric? If yes, then only we will use factor analysis, cluster analysis, and metric MDS. Now, important method of factor analysis. There are several methods of factor analysis, but they do not necessarily give same result. As such, factor analysis is not a single unique method, but a set of technique. Important methods of factor analysis are: in factor analysis also so many methods are there. We are using factor analysis with the help of these methods only. Centroid method. First is centroid method, second is the principal component method, third is the maximum likelihood method. Before we describe these methods of factor analysis, it seems to appropriate that some basic terms relating to factor analysis will be understood. Number one is factor. What is the meaning of factor? So a factor is an underlying dimension that account for several observed variable. There can be one or more factor depending upon the nature of the study and the number of variables involved in it. Factor loading. So what is factor loading? Factor loading are those values which explain how closely the variables are related to each one, okay, of the factors discovered. They are known as factor variable correlations. In fact, factor loading work as key to understanding what the factor mean. It is the absolute size of the loadings that is important in the interpretation of a factor. Next is communality, that is h square. Communality symbolized as h square shows how much of each variable is accounted for by the underlying factor taken together. A high value of communality means that not much of the variable is left over after whatever the factors represent is taken into consideration. It is worked out in respect of each variable as under: h square of the ith variable is equal to ith factor loading of factor A whole square plus ith factor loading of factor B whole square plus ith factor of factor loading of factor C, and so on. How many factors are there? According to that you have to do. Eigenvalue or eigenvalue is also known as latent root. When we take the sum of a squared value of factor loading relating to a factor, that then such sum is referred to as eigenvalue or latent root. Eigenvalue indicate the relative importance of each factor in accounting for the particular set of variable being analyzed. Now fifth one is total sum square. It is something like sum of SS we have done in earlier one, like ANOVA and INCOVA. When eigenvalues of all factors are totaled, the resulting value is termed as the total sum squares. This value when divided by the number of variable involved in a study results in an index that shows how the particular solution accounts for what all the variable taken together represent. If the variable are all very different from each other, this index will be low. And if they fall into one or more highly redundant groups, and if the extracted factors account for all the groups, the index will be approach unity. So these are the some important terms related to factor analysis. Now we will go to the first method, our first method, that is centroid method of factor analysis. This method of factor analysis, developed by L.L. Turnstone, was quite frequently used until about 1950, before the advent of large capacity high speed computers. The centroid method tends to maximize the sum loading disregarding signs. It is the method which extracts the largest sum of absolute loading for each factor in turn. It is defined by linear combination in which all weights are either +1 or -1. Okay, the main merit of this method is that it is relatively simple, can be understood very easily, and involves simpler computation. If one understands this method, it becomes easy to understand the mechanics involved in other methods of factor analysis. Means if you understand centroid method of factor analysis, then the rest of the two methods will become easier to understand. So what are the steps involved in this? So here the theoretical part of centroid method, that how to that means this is the algorithm to how to solve a centroid, how to solve questions. This method, it starts with a computation of matrix of correlations R, wherein unities are placed in a diagonal space. The product moment formula is used for working out the correlation coefficient. Second, if the correlation matrix so obtained happens to be positive manifold, that is disregarding the diagonal element, each variable has a large sum of positive correlation than of negative correlation. The centroid method requires that the weights for all variable be +1. In other words, the variable are not weighted, they are simply summed. But in some case the correlation matrix is not a positive manifold, then reflection must be made before the first centroid is obtained. So centroid method, now the next step for the centroid method is, the first centroid factor is determined as under the sum of the coefficient including the diagonal unity in each column of the correlation matrix is worked out. B. Then the sum of these column sums T is obtained. C. The sum of each column obtained as per A above is divided by the square root of T obtained in B above, resulting in what are called centroid loadings. This way, each centroid loading, one loading for one variable is computed. The full set of loadings so obtained constitute the first centroid factor, say A. Fourth step is to obtain second centroid factor, say B. One must first obtain a matrix of residual coefficients. For this purpose, the loading for the two variable on the first centroid factor are multiplied. This is done for all possible pair of variables. In each diagonal space is the square of the particular factor loading. The resulting matrix of factor cross products may be named as Q1. Then Q1 is subtracted element by element from the original matrix of correlation R, and the result in the first matrix of residual coefficient R1. After obtaining R1, one must reflect some of the variable in it, meaning thereby that some of the variables are given negative sign in the sum. This is usually done by inspection. The aim is doing this should be obtained a reflected matrix R1 dash, so which have the highest possible sum of a coefficient T. For any variable which is so reflected, the sign of all coefficient in that column and row for the residual matrix are changed. When this is done, the matrix is named as reflected matrix. So in this way we will do this loading on the second centroid factor are obtained for R1 dash. Similarly, for subsequent factor C and D, the same process outlined above is repeated. After the second centroid factor is obtained, cross product are computed forming matrix Q2. This is subtracted from R1 and not from R1 dash, resulting in R2. To obtain a third factor C, one should operate on R2 in the same way as on R1. First, sum of the variable would have to be reflected to maximize the sum of loadings, which would produce R2 dash. Loading would be computed from R2 dash as they were from R1 dash. Again, it would be necessary to give negative signs to the loading of variables which were reflected, which could result in the third centroid factor. Now, given this is the example in which we have to find out the factor analysis with the help of centroid method. Given is the following correlation matrix relating to 8 variables with unities in the diagonal space. Variables are 1 2 3 4 5 6 7 8 and the variables are 1 to 8 again. So in this matrix there are given correlation. This is the correlation matrix relating to 8 variables. Using the centroid method of factor analysis, work out the first and second centroid factor for the above information. So this is the correlation given is the correlation matrix R is a positive manifold and such the weights for the all variable be 1. Okay, this is the positive manifold, and if it is positive manifold, then the variables will be 1 plus 1. Okay, accordingly we calculate the first centroid factor as under this. This is the first centroid factor. How we will calculate it? This is the column and this is the rows and these are the columns. Here the values are already given. These values we are not calculated, it's just given here. This one value only we have written here. So we have to first do the column sum. Column sum is, we have to first do the column sum, and column sum is 3.662. Then this column sum is 3.263, 3.392, 3.385, this sum is 3.324, then 3.666, 3.587, 3.605. So what will happen? Sum of the column sum t means all this column sum is 27.884. Okay, and if you will do the square root of this, then it is 5.281. Okay, now we will first calculate the first centroid. So how to calculate the first centroid? But only you have to do what? Column sum divided by sum of column sum. Okay, means that is root t. We have to do column sum. Column sum is 3.662 divided by 5.281. Similarly, 3.263, 5.281, 3.392, 5.281, 3.385, 5.281. So if you will do this, you will get the values 6, 0.693, 0.693, 0.618, 0.642, 0.641. This is the first centroid factor A. Next is, so what we have done, whatever the value we have got, like 1 to 8, whatever the value we have got, that is first centroid factor, 0.693, 0.618, 0.642, 641. So that one we have written here. Now we have to find out second centroid factor. We first of all develop the first matrix of factor cross product we will do. So what is the process? Here you have to write the first centroid, here again you have to write the first centroid and do the cross product. Cross product means 0.693 is multiplied by 0.693, then whatever the result will be there, you will write here 0.693 with 0.612, then here you have to write result 0.693 into 0.42, then the result will be here. Suppose this result we have got with the multiplication of 0.641 with the multiplication with 0.629. Similarly, this result we have got with this and this, that is 0.6983 multiplied by 0.679. So this is the way we will first find the first matrix of factor cross product, that is Q1. Afterwards, what we will do, now we obtain the first matrix of residual coefficient R1 by abstracting Q1 from R as shown below. Okay, we have to subtract Q1. Okay, subtracting Q1 with R, this is the Q1, and we have to subtract this Q1 with R. Okay, so what is our R here? So we have to first subtract it. Okay, when you are going to subtract it, R is our 1. So if you will subtract 1 minus 0. See this value, this is if suppose this one is 0.52, so how we have got 0.52? 0.52 we can get 0. This is 1 minus 0.42, 0.42, then this value is 0.52. Okay, now this is the value. So like this you have to just subtract and get the values here. Okay, you have to get the values here. Okay, now next reflecting the variables 3, 4, 6 and 7. Here first we will do this. We obtain reflected matrix of residual 1 R1 dash as under, then we can extract second centroid factor, and in this way we will get, after getting this value, this is the reflected matrix of residual coefficient and extraction of second centroid. So these are the values. We will again do the same thing for the second table also. Column sum is 2.580, 2.642, 2.470, 2.757, and all these are the column sum. Sum of column sums are 20.987 and root t is 4.581. Second centroid we will find out, as you know that column sum divided by this, so you will get these values, and afterwards we will just write all the centroid factor and centroid factor B, and you will get the required result. You will get the second centroid table also, and factor loading. So centroid factor A is this, and centroid factor B is this. B is 0.56 3, 0.577, then minus 0.3539, minus 602. So these are the values which we have obtained with the help of the previous table. Okay, so here you have to understand that how to find out extraction, or how to extract a second centroid factor, what is reflected matrix of residual coefficient, and more important is to understand how we have got these results. Okay, so this is all about the centroid method for factor analysis. In next video we will study principal component method of factor analysis.